Hi everybody, welcome to the Developing a Redis Module webinar from Redis Labs and Hackerearth. My name is Itamar Haber and thank you for joining us. I'd like to kick off by first presenting ourselves. So we are Redis, the open source software, the leading in-memory database platform for any high throughput, low latency workload, whether OLTP or OLAP. And I'm from Redis Labs, which is the open source home and the commercial provider of Redis. I work there as a chief developer advocate. And please, if you ever want to know anything about Redis, just feel free to reach out. Before we continue, or actually even start this webinar, I'd like to point your attention to the little gizmo you have on the edge of your screen, the webinars panel. You can use it to ask me questions, which I'll answer once the first part of the webinar, that is with the slides, will end. So please familiarize yourself with it. You can also raise your hand. In fact, please do raise your hand. There's a button there. Raise your hand if you've ever heard about Redis. So I'll have sort of a notion of your previous knowledge. So anyone who heard about Redis is more than welcome to raise his hand now. All right, moving on. We are here to kick off the Redis Modules Hackathon. This webinar is the actual kickoff, and the hackathon is at this URL. You can reach the hackathon's page there. It opens today and ends on November 12th. We are doing a global distributed as well as local events. That means that anyone can attend either part, and we urge you to submit your modules in order to participate and a chance to win cash prizes and gain world fame. For those of you who don't know about Redis, or even for those of you who do know about Redis, I'd like to go through a couple of slides to give you just a very, very brief sense of what Redis is. It's by no means a comprehensive introduction to Redis, but you can read more about Redis online. So Redis is an acronym. It stands for Remote Dictionary Server, but actually it's much, much more. The most important thing about Redis is how you pronounce it. It's pronounced Redis, and it's open source. You can get the sources. In fact, I urge you to get the sources right here from GitHub, from Antires's repository. And it's provided under the very permissive 3-clause BSD license, which basically means use it and you don't owe anyone anything. Redis is an in-memory database, which means that all the data is managed in RAM, that is written to and read from RAM, but Redis Labs also offers the flash options for the option for Redis if you're interested. Redis is a database. It's a very unique database in the sense that it provides support for about 9 data structures, and 7 is just my mistake. Let's go on. If you've heard about Redis, or even if this is the first time you've heard about Redis, then you should know that Redis is mainly developed and maintained mostly by Salvatore Sanfilippo, also known as Antires, and his open source team at Redis Labs. A very brief overview of the history of Redis. It started way back in 2009, about 7 years ago. The first version of Redis was released, and we've just released the most recent version a month ago. It's often called the Leatherman of databases in the sense that it's mostly used as a database cache and message broker, but there are in fact a lot of use cases which I'm not going to cover today for Redis, and it's one of the most popular databases out there. In fact, most of the applications out there, modern applications, use it. It has a few extra features besides the ones that I've mentioned. Again, this is not a comprehensive overview, so you're more than welcome to go online and educate yourself about Redis in general. But the reason that this webinar is taking place and the hackathon is because next version of Redis, version 4.0, will introduce modules. We expect it to be released in a month or two by the end of the year at any case. And this is what we're going to discuss today. A very, very, very short one-on-one on Redis. Redis is a NoSQL database in the sense that it's not a SQL database. It doesn't have an explicit schema. In fact, it has only an implicit schema, the one that you decide upon by the pattern of your keys and the data structures that you use, and you access the data by key. It's a sort of key value store. Only in Redis, the way it goes is that a key allows you to access not a value but a data structure that in turn holds the actual values or the data. Redis supports quite a few of these data structures that it supports inherently. From version 1 we had strings. The basic string is just a byte array up to ½ a gigabyte in size, and linked lists and unordered sets. Then we got the sorted sets, which are basically just sets but with an order, and the hashes, which are your object map or associative array, if you will. There are a few other specialized data structures like bit arrays and bit fields, the geosets for geospatial indexing, and the amazing hyperlog. But in version 4, this is all going to change, and I guess we're going to see a lot more data structures like the neural network that I'll discuss or present later, because we'll have modules. So with this brief introduction, you should also know how to work with Redis. As I've mentioned earlier, Redis is a server. It's a database server, so you'll need a client in order to connect to it. You can choose one of the 150 or so open source clients that are available in practically any conceivable programming language. And once you have the client, all you need to do is make a request to the server, of course, after connecting to it, such as ping, and the server should reply to you with the reply. In this case, it's pong. Here's a little demo just to get you started with Redis. I'm using the Redis CLI. The Redis CLI, or command line interface, is a utility that's bundled with Redis. It's actually a client. It can be used either as an interactive interface, or you can just shoot off one command, once-off commands from the command line. And this very brief demo shows you how you can set a key to a value, how you can get it and manipulate it in different interesting ways. I'm not going to review the Redis commands. This is probably something for a different session. Redis, from the beginning, pitted itself as a very flexible tool. The idea is to give the user the building blocks, sort of like Lego blocks, if you will, to build almost or model almost anything with it. And this has been the initial goal from version 001. Then Redis gained an interesting capability or ability, which we call composability, the ability to basically bundle up together groups of commands and run them together as transactions, starting version 1.2, and continuing with server embedded Lua scripts, which basically allow you to compose any workflow you want. But in version 4, we're pushing this even further with extendability. That is the ability to extend Redis with modules, with new data structures and commands. So what are modules, or actually, if you will, plugins? What you're seeing now is the Redis release note from Salvatore, the creator of Redis, back in 2009, and you can see that this message has this very, very interesting sentence where Salvatore openly discusses the ability or the possibility of adding plugins, which is exactly what we got now. It took slightly longer than perhaps some would have expected. The history of plugins, modules, is quite interesting, although not in the scope of this webinar. The important thing is that now we'll have modules. But what was Redis before modules? I've mentioned that Redis is the most popular NoSQL database. It's being used all over the world for almost any purpose, but as such an amazing and generic tool, there are always some use cases, some edge cases that need special care. Yes, you can compose things with transaction and Lua, but not everything can be optimally solved that way. And sometimes Redis users want to have this extra ability to go further to cater to their specific needs. However, the open source community and the development team has its own agenda, primarily stabilizing Redis, making it more useful to everybody, and not necessarily trying to resolve every use case out there, as esoteric as it may be. So before we had modules, what could you do if you had a feature that you needed added to Redis? You could either submit a feature request to the community, but most chances are that unless the feature is tremendously important and relevant to everyone, most chances are it won't gain a lot of traction there. So you could go ahead and actually code that feature on top of the Redis core open source and submit it as a pull request. However, just like other open source projects, pull requests are not guaranteed to be pulled in and merged with the upstream repository. We're looking for quality contributions that go in line with the Redis core, so naturally not everything gets bundled. The last option is forking Redis. It is an open source software, so you can fork it, but that means that you'll need to play catch with the upstream version and keep on maintaining your own fork forever, which is kind of gruesome. With modules, the entire thing changes. This is basically a game changer for Redis in total. The core Redis still fits all the use cases it used to fit, but with modules you can extend Redis for any special use case or need that you have, and this basically gives the basis for the establishment of a whole new community that's focused on making modules and using modules for Redis. And as Salvatore himself said, this gives power to the users to go faster. And this means faster than the Redis core development itself, but, and it's quite funny, it also gives the power to the developers to go faster. And the neural network module is an example of that. Salvatore had written a module which will be added to Redis's next version, bundled with Redis, that basically adds a new data structure. So this was definitely an unexpected boon of modules. What can you expect from the modules? Well, nothing is impossible, and this is why we're here, or rather why you're here, because I want to show you how you can make the impossible possible yourselves. Redis modules are basically, or not just basically, but actually just libraries. These are dynamically loaded libraries that the server can load upon request. They are future compatible in the sense that the API that they expose and the binaries are fully backward compatible, so you can write your module today and know that once that future versions of Redis will work with it without a glitch. Modules are and will be mostly written in C or C++, the language in which Redis is written in, but you can basically use anything that has C bindings to Redis module. And the neat thing about modules is that they give you a way to work and operate nearly as fast as the core Redis itself. And if there's one thing that Redis is known for, is its performance and speed. Modules let you basically process the data where it's at. So instead of moving data back and forth between the client and the server, you can just run your logic exactly where the data is, which lets you reap a lot of gains in terms of performance and latency. The modules let you compose, just like transactions in Lua script. They let you compose your own workflows by calling the core and other modules commands, but they also allow you to extend Redis, as I've mentioned, with new structures, commands, and libraries. This is a very top-level example of what a module looks like. We're back again in the Redis CLI, the Redis command line interface. And what I'm showing you here is a comparison between two commands. One of them is a core Redis command. The other is a module command, command that was implemented using a module. So the core command is called echo. It's a Redis command which basically just repeats whatever you send it. So you can see that when I say echo alpha, Redis responds with alpha to me. The second command that I'm running is the module load command, which basically just loads a library. This is the name of the library, example.so. And then I'm using the command that the module provides, which is basically the same command. It's called echo, and it does the same thing, returns to you whatever you send to it. But this time it's the module doing it and not Redis itself. Just to whet your eyes on what it means to write a module, this example library is implemented in a single file called example.c, and it has only 13 lines, so it's pretty short. It shows you that writing a module is very, very simple. It doesn't have to be something complex. And these two last lines show you how you can actually go ahead and compile and link your module. And that's all you need to do in order to write a module. Pretty impressive and very powerful. Some modules or some examples of modules that were developed up until now. This is by no means a comprehensive list. These are some of the modules I know of. It doesn't mean that it's all the modules in the world. I've mentioned Neural Redis. It's basically a neural network that you can use inside Redis online. You train it by showing it a few examples of what of inputs and outputs that you are sure about, and then you can just let it train itself online in a non-blocking fashion and start asking it questions according to the data that you taught it, and it's pretty impressive to see it in action. There's also a Redis search module which basically implements a full text search engine built by my peer and colleague Dvir here at Redis Labs. One of the features that many users have asked for is a full-blown text search in Redis. It was possible to do some of that previously, but with modules you can get much better performance and much more robust functionality, as well as other modules that basically let you add little data structures like the count, means, catch, or Bloom filters, or the Tt-digest, which is used for quantiles and percentiles estimation, and a lot more doing with image processing, security, machine learning, you name it. Everything is possible. With modules, there are more examples at the Redis Modules Hub, and you can go ahead and look there at your own time. The next part of my session, I'm going to show you a little of the Redis Modules API. It's just like a brief taste to get you started, but it's, again, it's not a replacement for a whole tutorial about modules. You'll have to start that yourself by reading and experimenting and exploring. The API is basically, or the modules API is where most of the development effort for the modules took place, and this is basically the reason why we didn't have modules up until now. The main challenge with designing this API was basically to abstract and isolate the internals of Redis, so modules developers do not need to be familiar with how Redis is implemented internally, and this is also mandatory to ensure the backward compatibility of modules with future versions of Redis. The API is basically the binding contract of the server with the module developer, and once we go live, once we go GA later this year, it will not be broken. You can see the API as divided to three main conceptual layers, which I'll describe right now. The first layer, which is probably the most the least interesting but still very important, is the operational layer. It consists of all the different calls and methods that you need in order to administer and manage your module inside Redis, whether it's registering it, accessing memory, doing replication, handling replies, and so forth. Then there's a high-level API, which basically consists of a single command, I'll show you that later, which allows you to access Redis from a client, or rather a dummy client inside of Redis. It lets you access any of Redis's capabilities through that. And then there's the low API, which is the most powerful one because it provides you an almost native access to everything that Redis has and much more. If you remember the example I showed you earlier, the echo command, so I'd like to take you through very briefly and quickly through the source of that command, the example.c file, and this example uses strictly only the operational layer API. It doesn't actually use anything from Redis, not the high-level API, neither the low-level API in order to do echo, because echo is a very simple functionality. So this is it. These are the 13 lines I talked about earlier. They're all here, but let's see what this is made of a little in a more orderly fashion. So beginning at the top includes one line, include Redis Module.h. Redis Module.h is the header file which contains the API's definition. This is the only file actually that you need in order to start writing in a Redis module. You just copy it from the repository of Redis, drop it into your project, and you're ready to go. This is all you need in order to start to write your own module. The next thing you should note is the Redis module onload command. This is the hook which Redis looks for in your modules library and calls once the module is loaded. This is where you bootstrap your module, register it, and initialize anything you need to initialize. Note this parameter, the CTX parameter, or the Redis module CTX context that you get. The context is the module's calls execution context. It basically acts as a housekeeping internal memory data structure that Redis maintains, and it's used by most calls to the API, so you just pass it along from one call to another as needed. And the only method, if I'm not mistaken, that it exposes is for you to get the client ID if you need it in your module in order to distinguish between different clients that connect to Redis, of course, and use the module. Moving forward with this exemplary module, you can see the contents or the internals of the onload command. It's based or function. It's basically made up of two calls, two ifs that check for success or die trying to execute that. The first call is to Redis module init, which initializes this module, and the second command registers the single command that this module exposes, the echo command. It's called the create command, and you just send Redis the command that you want with a pointer to the function and a bunch of other arguments in order to make this module expose it to the end user. Looking at the echo function, which implements the echo command, you can see that I'm doing two things here with the arguments. First, you can see the first argument is the context, which get passed here, and then two additional arguments as it is in C world, the arguments array and a count of the arguments. So the first thing I'm checking is whether I have the right number of arguments. That is 2. I expect to get 2 arguments, the command's name and the argument for that command, which I will repeat. And if there's no error, I just return a reply with Redis Module underscore reply with a string, and I just reply with the same argument that the user had sent. So this is the simplest module perhaps you can write, and it uses only the operational layer. We register the module, we check the arguments, we reply, but nothing major going on here. The reply, you can actually send replies to the user, any supported form of replies. So Redis Module underscore reply with has several flavors. You can reply with an error, with a null, with an integer, a string, an array, and so forth. Moving on to the high-level API now, after we've seen the operational one. So as I mentioned, it's made up of just a single command or a single method. It's called the Redis Module underscore call. And if you're familiar with Lua scripting in Redis, or if you've used Redis as a developer, as an application developer in the past, you'll be very familiar with the use of this command. You basically get access to a sort of client, a Redis client, which you can give a Redis command and its arguments, and it will reply with a Redis-ish reply to your needs. So let's see how that works by using a new example, or rather the same example that I showed you earlier, the echo command, only now it's going to use the high-level API. I want to stress that this example is highly unrealistic. It doesn't make sense to implement a module in this way, but it is educational because it shows you how to use the high-level API. So everything stays the same inside the echo command, the new echo command, or the educational high-level API echo command. We still check the arguments, but there are a couple of changes. But here are the changes. First, notice this call to Redis module auto memory. I'll discuss this shortly. And then you can see that my reply, that in order to obtain my reply, I'm actually calling the Redis module underscore call method, and I'm calling Redis's core echo command with the single argument that the user had provided me. So basically this calls Redis's echo and returns the reply into the pointer called rep. And all I need to do then is return the reply that Redis replied with to the user. It's a bit confusing when I say it, but the code is extremely clear. About auto memory, so once you start doing more complex stuff inside your module, you're going to start opening keys, allocating memory, so forth. Redis has this auto-magical mechanism that manages memory for you, so you don't have to free stuff like C makes you, and it has a bunch of other calls that you can use to control what you're doing. So this was the high-level API, and I'd like to compare and contrast it with the low-level API with this very detailed diagram. On the left side, you can see the user using an application. The application inside has this circle. The circle represents the Redis client. Now, with the Redis client, the application does a get foo, basically reads the value from foo and sends it to Redis. Redis's core processes this request, fetches the data from the server, and replies with the value under the key. And this is basically the workflow of any Redis command, any core Redis command up until now. This is the workflow of how it's working. With modules, this changes slightly because now the application basically shoots the command like echo or example.echo, but the module itself gets to handle it. With the high-level API, as I've shown you, we call Redis itself with the Redis module underscore call method, and the core itself goes to the data. In our case, there was no data, but will go to the data and then returns a reply which gets sent back to the module, which then in turn sends it back to the application itself. This is one way of doing things. However, the low-level API does exactly what you'd expect it to. It allows the module developer to almost go around Redis's core, or rather it provides an almost native access to the data and data structures and abilities that Redis provides, and provides basically a lot of freedom, flexibility, and much better performance than the high-level API. There are a lot of things that you can do with the low-level API, like managing your keys, accessing the data structure, you get direct memory access to strings, for example, and you can also go and just implement your own new data structure, register a new data structure in Redis by giving it a type, teaching Redis, or implementing 5 callbacks. 3 of them are needed for persistence, if I'm not mistaken. Another doesn't really matter what each of them does, but just by implementing 5 callbacks, you can add your own custom data type, which in turn gets treated just like any other data type in Redis. And you can also do asynchronous processing with blocking commands, just like Redis's blocking commands, if you're familiar with them, and much, much more. We don't have time to cover the entire extent of the API. These are just the tastes. So today we're launching the Redis Modules Hackathon, and this is the reason why we're here. If you want to join it, I encourage you to do so. It's a great opportunity to learn new stuff and also help the community by coding and developing your own modules that will help other people probably. If you have an amazing idea, what are you waiting for? Just start coding. The hackathon is open to individuals and teams globally, so you can sign up to the global hackathon. You don't have to do anything but submit your use your email ID and register, start coding, and submit your hacks and modules until the final date to be included in the competition. If you want, you can also join us in San Francisco and Tel Aviv on November 11th and 12th, where we'll do an on-site sprint. We'll also do modules, so if you're a part of the global hackathon or not, you can join us there and work on your modules and submit your module there. And again, you can win valuable cash prizes and gain world fame. To develop your own module, all you need is, in terms of tools, your favorite text editor and a compiler. As I've shown you earlier, you'll need a C compiler, perhaps, if you're working in C, a C++ compiler. If not, if working in C++ and so forth. The next thing you want to do is grab Redis from the unstable branch. This branch has support for modules, and then look at everything and read everything under the SRC modules directory. This has the API's documentation, a few introductory articles on how to implement modules, and as well as code examples. You can also go ahead and grab and clone our SDK. This SDK is optional. You don't have to use it, but it's very convenient. You can just clone it and start coding. It compiles, so you have all the stuff set up for you to start writing your own modules from scratch. And it has a few helper functions and libraries that we've developed and found useful for modules developers. I'd also like to provide you with a few guidelines on how you should tackle the task of designing a module in terms of its API and generally. The first and perhaps most important suggestion is just keep it simple. Don't do complex stuff. This is in the spirit of Redis. We like simplicity and we're against complexity, but try making it as generic as possible. Assume nothing. Give the user control over everything pertinent. Don't overload them with everything, but make sure that your module, the API, is generic enough to be used just like any other Redis capability. If you're familiar with Redis, one of the important API design considerations is that you implicitly manage and create the data structures. You don't have to declare beforehand that a specific data structure is needed, so I can just start adding something to a list that doesn't exist and Redis will create it for me. The same is expected from a it's considered basically an anti-pattern to create something explicitly unless it's absolutely mandatory. Also note that your commands or the module's capabilities should expose and be very, very clear about what they're doing in terms of costs in space and time complexities. That is, how much memory they're going to take and how much time it's going to take each command to run depending on the input. This is perhaps one of Redis's most forthcoming transparencies, the fact that users know the cost of everything. If you're looking for inspiration, if you don't know how to model a command or API, go through Redis's core API, just the regular commands, and draw inspiration from there. This is the best way, just imitate it. A few other guidelines or pointers. Remember that because Redis is an in-memory, blazingly fast database, you want to keep your modules adhering to the same behavior. That is, performance is crucial. You have to have good performance, otherwise why use Redis? And RAM consumption is very important and only secondary to that. That is, we're using RAM because RAM is fast, but don't just spend RAM all over the place because it's still a scarce resource. So use what you need, don't abuse it. As for your submissions, remember that code isn't everything. We expect to see documentation, tests, benchmarks, example of use, anything that accompanies the module and makes it substantial instead of just a few lines of code. Make sure that you impress us, make it useful, and make it awesome, and you will win. This is all I had for you today. I think we're right about half through our time slot. Oh, I even took a few more minutes. So I'd like to open the stage for questions. Please feel free to enter them in in your webinar panel. I already have a few questions here, so let me review and start answering them, but feel free to keep them coming as I go along. So, hi Ramya. What's actually done in with Redis? It's all about storage or something else. So Redis is a database. You store data in it. You store and manage the data in it. If you're familiar with application development, you'll know that databases are usually a critical component of every application stack. So Redis provides you that. It's special in the sense that it's not a relational database and it's not like any other database. It is what it is, and the special things about it, and I think I've mentioned it during my webinar a few times, is its performance, its simplicity, its flexibility. These all probably led to the fact that Redis is used by everyone that I know of. Basically, it's in every application stack, either both known applications and very popular ones like Twitter, Netflix, you name the app, it's there, as well as other real-world scenarios where you need the performance and the abilities to scale your application to handle massive amounts of data in very low latencies. Next question. How many Redis modules have been developed so far from Vivexo? I really don't know. I would say tens. We at Redis Labs have developed, I think, at least over 20 by now. Not all of them have been unveiled, but will be announced by the end of the year. Text search is one of them, but we're also working on very interesting machine learning modules with in cooperation with Spark and so forth, adding JSON support to Redis, all sorts of things. And the community itself has also written, members from the community have also written modules for statistics. I've seen a module that does locking, all sorts of things. Really, there's two other modules, a bridge for Python modules and a bridge for Go modules. And basically, it's just limited by the imagination of you, by your own imagination. Next question is from Hoshank. Would Redis be a participant in Google? We don't know. Code of Summer, we don't know. Please feel free to reach out to me privately with that if you want to discuss. What is the actual size of each module? Ramya asks, what's the actual size? So there's no actual size. It really depends on what you put there. A module could be a few kilobytes, like the example.c module is just a few kilobytes. If anything, it's a very simple module, so it has a few symbols and just a few lines of code in it. But some of our modules have grown quite complex, spanning thousands and many thousands of code lines. Plus the fact that modules actually allow you to bundle or link with existing libraries. So if there's an existing library you want to pull into your module or link with your module, anything you can grab can fit there. So there's no size limit for Redis modules, and there's no one size for them. Last question that I have here, unless someone else raises their hand or asks a question. I can see that how is Redis different from other databases like Couchbase and MongoDB? That's a great question. I'm not that familiar with these technologies, but Redis is different from Mongo in the sense that MongoDB is a document-based, disk-based database. Couchbase has some similarities, having grown out of the key value memcache world, but it's taken an entirely different course. This is not actually a comparison between Redis and the others. If you search online, you can find a lot of comparisons. I'm not necessarily suggesting that any one tool is good for everything. Each tool has its merits and use cases. Today we're talking about modules. Hi Adam, great seeing you here too. You're asking who and where I can access, very good question. Who can help me with questions regarding modules development? So we can help you. You can either post your questions at the discussion board at Hackerearth. You can reach us online, whether myself or Dvir. You can go out to the community, to the RedisDB forum or the Reddit, and ask your questions there. Twitter, we're trying to be all over the place, and or just come visit us from Herzliya in our office and at Ramat HaChayal, and we'll work with you. If there are any more questions, we still have a few minutes left. Feel free to put them here. Again, I'd like to thank everyone who joined us here. It's been a spectacular attendance, and I hope to see all of you taking part in the hackathon, which launches today, October the 17th, and will run until November the 12th. Once the hackathon ends, the judges will sit and evaluate all the submissions. We have grand prizes both for everyone who participates as well as the on-site event. So if you're either in San Francisco or in Tel Aviv during the on November 11th and 12th, you're more than welcome to join us there and work with us on your modules hand in hand. And two questions, great. So what is the use of modules in Redis? The use of modules in Redis is basically taking Redis to any place it hadn't been there before, and the change is that you can do it without interfering with Redis's or depending on Redis's core development. So any use case that you think Redis could help you with, and for which Redis doesn't have an optimal response or capability, you can just go ahead and add it. So I've mentioned full text search, support for JSON documents. We are building secondary indexes with Redis. We have a module that implements a decision tree. We have a module that works with Spark to better address machine learning aspects. Virtually everything is possible, better security, working with other databases if you want to pull information from another database and read it into Redis, basically extending Redis in every conceivable way. Another question is, how are they developed? So the modules are developed mainly using C or C++, but you can use basically anything that can provide C bindings. Redis expects to have a hook into your library, the Redis onload function. This is all it cares about. So you can, if it does C bindings, you can use it to write Redis modules. People are asking, where can I find this webinar? Offline link. That would probably be on the same page where you registered. What could be one bottleneck in situations in Redis? I'm sorry, Ved. So Ved is asking, I guess, for a module idea that he can take a bottleneck and optimize. This is kind of out of scope for here. If you want, you can discuss it in the platform, in the Hackerearth platform, raise the question, try to find other people who work with you on that. Abhishek is asking, what if my data doesn't fit in memory? That's a good question, although it doesn't have to do with modules. It has to do with Redis. If your data doesn't fit in memory, Redis will not let you basically add more data, just like if your data doesn't fit in a disk. Redis can be configured in a number of different ways to handle out-of-memory behavior. You can read about that in the documentation or reach out to me later. So we're getting more questions. I'll just keep on going until I cover everything. Feel free to stick on or hang on, but the questions are actually coming in now, so I'll continue reviewing them. Ramya is asking how to get the inbuilt modules of Redis other than developing new one. I'm not sure I understand that. The question, Redis has currently no built-in modules. Modules will only be introduced in the next version, and there may be some modules that will be a part of the core Redis distribution. Neural Redis being one of them, and once they're part of the core distribution, they'll be a part of the distribution, so you won't have to do anything special to get them. Other modules, you just it depends on the module. Our modules are open source, so you can just take the source, follow the instructions on how to compile it, usually just type make, and you have the module. But every module is different potentially, so there's no one way. Is development of Redis module possible in Java? That's a good question. I believe it is, although I wouldn't necessarily go that way, keeping in mind that you want to keep everything very, very lean and very, very fast. However, I'm pretty sure you can bind Java to C and vice versa. So a good Java person with enough knowledge could probably hook the two together. Next question. Is there support for developing, good question, Ankit, is there support for developing Redis modules on Windows operating system? Redis itself does not run on Windows officially, so it's only for Unix-like systems. There is a Windows fork maintained by the Microsoft open source team. However, I don't think that their fork is currently module compatible. It hasn't been. I don't think they've gotten that far in porting their fork. That said, you could develop the module itself on Windows. I guess so. If there's a Windows development environment that can compile for Linux, it's perfectly possible. The C is the same C, so it's just a matter of setting up your development environment. However, I wouldn't recommend on that. It's fairly easy to install a virtual machine with Linux as a development environment. You just grab whatever flavor of Linux you want, and you're ready to go. I would definitely recommend doing that instead of trying to pave new ways in Windows, unless you're up to it. Another question, it would be helpful if we could get any link to tutorials on Redis. So the hackathon page has a bunch of links to tutorials on Redis, the Redis site, modules development. There's a lot of material out there. Google is your friend here. If you type Redis, I'm sure you'll find a lot of material. And again, we're here to help you. So if you have questions, just feel free to reach out through the Hackerearth platform, online, via email, whatever, and we'll try to assist. I think we're running out of questions, which is great. Excellent. Thank you everyone for attending this webinar, and hoping to see you online and offline and in the future. Good luck.